Hello everyone, welcome to my physics class, Standard 8, Chapter 3, which deals with force and pressure. In this chapter, we will study about moment of force and pressure. First of all, we discuss about moment of force, and after that we will discuss about pressure. Moment of force. When force is applied on a door handle, it tends to turn the door about the hinges. When we apply force on a door handle, it either opens or closes the door about the hinge. This rotating or turning effect of force about a fixed point is called moment of force. The turning effect produced by a force about a fixed point is called the moment of force. The moment of force or the turning effect is maximum if the force applied to the plane of the body, if the force applied is perpendicular to the plane of the body and the point of application is away from the fixed point. Let us consider a body which is fixed or pivoted at a point O. This is the point O where the body is pivoted or fixed. Force F is applied on the body at point P. This applied force F turns the body, rotates the body about the vertical axis passing through the point O and the direction shown by the arrow head. The distance between the point at which the force is applied, that is the at P, and the fixed point is O. So this distance is the OP. Therefore, moment of force about point O is equal to force into perpendicular distance of force from point O, that is F into OP. Since OP is the distance and it is denoted by P, moment of force is denoted by tau. So tau is equal to F into D. F is the force applied on the body. D is the perpendicular distance between the point of application of force and the fixed point at which the body is pivoted or fixed. If force is measured in Newton and distance is measured in meter, then unit of moment of force is Newton meter. The moment of force on a body is said to be 1 Newton meter if a force of 1 Newton acts on a body at a distance of 1 meter from the axis of rotation. The turning effect produced on the body by a force may be either clockwise or anti-clockwise. That is depending upon on the point of application of force and the direction of force. If the turning effect on the body is anti-clockwise, the moment of force is called anti-clockwise moment. If the turning effect up on the body is clockwise, then the moment of force is called clockwise momentum. Anti-clockwise momentum is taken as positive and clockwise moment is taken as negative. Remember, anti-clockwise moment is taken as positive and clockwise moment is taken as negative. In figure A, anti-clockwise moment produced in a pivoted disc and axle by changing the point of application of force. The arrowhead shows the direction of motion, direction of turning effect, direction of moment of force. That is anti-clockwise momentum. This is the fixed point. If the force is applied at point O, when the force is applied at point O, the body, it produces turning effect along the direction as shown by the arrowhead. In another case, the force is applied at point B, Now the body rotates in the clockwise movement, in the clockwise direction, and the movement so produced is called clockwise movement. Clockwise movement is always taken as negative, anti-clockwise movement is taken as positive. Now examples of turning effect of force: opening or closing a door. To open or shut a door or close a door, one has to apply force normal to the door at its handle. The handle is present at a maximum possible distance from the hinges. To close or open the door, we either push or pull the door near the handle. If we apply force at a point Q between the handle and the hinge, greater force is required to open or close the door. If we apply force at the hinge, it will be extremely difficult to open or close the door. In the formula of moment of force, we have seen that tau is equal to F into T when distance between the force of application of force and the fixed point increases, less amount of force is required to produce turning effect. If the distance, when the distance between the fixed point and the point of application of force decreases, more amount of force is required to produce the turning effect. The turning effect of force is more if the distance between the force and the hinge is more. The turning effect of force is less if the distance between the force and the hinge is less. If we apply force at the hinge, it will be extremely difficult to open or close the door, because if we apply force at the hinge, means the distance between the perpendicular distance tends to 0. So it does not produce any turning effect. This is why it will be extremely difficult to either open or close the door. You see, this is the hinge, so this is the handle of the door, and these are the hinge. We apply force on the handle which is perpendicular to the hinge, which is normal to the hinge. Now, a wrench is used to tighten or unwind knots. A wrench has a long handle and a force is applied normally at the handle. This is the wrench, and this D denotes the distance of the perpendicular distance of point of application of force and the fixed point. This knot is the fixed point. Here the force is applied. Force is applied along the downward direction, which is perpendicular to the distance between the point of application of force and fixed point. Both these, and when force is applied, it produces turning effect and helps to tighten or unwind the knot. Turning effect is the maximum if force applied is perpendicular to the plane of the body. If the force applied is perpendicular to the plane of the body and the point of application is away from the fixed point, if the distance increases, less amount of force is required to produce turning effect. Numerical problems. A person applied 10 Newton force to open a door with its opening handle located at a distance of 0.5 meter from the hinges. Find the turning effect. On reading the question, we found that, or in the question it is given that force F is equal to 10 Newton, distance from the pivot, that is D, is equal to 0.5 meter. So moment of force is equal to force applied into distance from the pivot. So moment of force is equal to F into D. F is equal to 10 Newton. Distance is equal to 0.5 meter. So 10 into 0.5, that is 5 Newton meter. A spanner is used to unwind a nut. A force of 50 Newton is applied to the end of the spanner, which is 5 meter away from the center of the knot. Calculate the moment of force when spanner is horizontal. Force F is equal to 50 Newton. Distance D is equal to 5 meter. Moment of force tau is equal to F into D. So 50 into 5, 250 Newton meter. A person applies 15 Newton force to open a door with its handle producing turning effect 30 Newton meter. At what distance is the handle located from the hinge? It is given that force is equal to 15 Newton, turning effect or moment of force is 30 Newton meter. And we have to find here the distance, perpendicular distance between the force, between the fixed point or pivoted point and the point of application of force. We know that moment of force is equal to force applied into distance. So distance is equal to moment of force by force applied. So moment of force is equal to 30 Newton meter by 15 Newton. If we divide 30 by 15, we get 20, and the unit of distance is meter. This is all about moment of force or turning effect produced by a force when the force is applied on a body. Now we discuss about pressure. The amount of force acting per unit area of an object is called pressure. Again, pressure. The amount of force acting per unit area of an object is called pressure. It means that pressure of an object depends on the force applied on the object and the area of contact between the objects. Between the two objects, out of these two objects, one object exert force and the other on which force is applied. Carefully observe the knife while we try to chop vegetables using knife. We found that the sharp side of the knife is used to cut vegetables. If we would try to cut the vegetables from the blunt side, we'll have to apply more force in comparison to the sharp side. So let us perform an activity to understand the relation between force and contact, between pressure and area of contact. Take a sharp thumb pin, a blunt iron nail, and a cardboard. First, we have to take the nail with the blunt end and press it on the cardboard. We observe that the thumb pin with the blunt end needs more pressure. Now take the thumb pin and press it with the pointed end on the cardboard. You'll observe that the thumb pin with pointed end will pierce the cardboard easily as compared to the iron nail with blunt end. In case of blunt end, the area of contact increases as compared to that of sharp pointed end. In case of sharp pointed end, area of contact is smaller as compared to that of blunt end. So when the area of contact increases, pressure decreases. When the area of contact increases, pressure when the area of contact increases, force decreases. When the area of contact decreases, force increases. Pressure increases. So while cutting iron nail, while a thumb pin entered into the cardboard with blunt nail, it requires more pressure. The area of contact of the pointed pin is less as compared to the area of the contact of the pin with blunt end. So the thumb pin exert more pressure and could pierce through the board easily. Now, pressure is calculated using the following formula. Pressure is equal to force by area on which the force acts. So P is equal to F by A. P stands for pressure, F stands for force, and A stands for area. Unit of pressure is Pascal. If force is measured in Newton and area is measured in meter square, then pressure is equal to 1 Newton by meter square, which is Pascal. So SI unit of pressure is Pascal. From the expression given below above, the following conclusion can be drawn. For a given force, if the force is kept constant, smaller area of contact, the higher will be the pressure exerted on a body. For a given force, when the force is kept constant, the larger area of contact, the larger area of contact, the lesser will be the pressure exerted on a body. For a fixed area of contact, the pressure exerted increases with increase in the applied force or vice versa. These are the very important points. You all have to remember these points. Now, numerical problems. Calculate the pressure produced when a force of 50 Newton is applied over an area of 10 meters square. Here, force is equal to 50 Newton, area is equal to 10 meters square. So pressure is equal to force by area. That is 50 Newton by 10 meters square. If we divide 50 by 10, we get 5 Newton per meter square or 5 Pascal. A man exerts pressure of 14 Pascal by applying a force of 70 Newton on a box. Calculate the area over which the force is applied. Here, force, given that force is equal to 70 Newton, pressure is equal to 14 Pascal. We have to find here the area of contact. We know that pressure is equal to force by area. This implies that area is equal to force by pressure. So force 70 Newton by pressure 14 Pascal. Dividing 70 by 14, we get 5 meter square. Hence, the area over which the force is applied is 5 meter square. This is all about the moment of force and pressure. In the next video lecture, we discuss about the force exerted by liquid, construction of manometer, application of liquid force, etc. and etc. Thank you very much.